here, what is I'm talking about intelligence of data. So now I say about data's evolutions. So just try to imagine like the data they are evolving like the human beings, okay, from very doors until intelligence. And I mean like the intelligence level of data currently is something at this level, okay? And we hope that in very soon they will come up in this level in intelligence like like the data they have ability to think of, and also they can prepare some information or wisdom to give to the users. Not waiting until the user try to extract the knowledge or the wisdom or the knowledge from the data anymore. Okay, how we can do that? Because right now, I think this could be the time, because right now you can say like data right now is very huge. Okay, so you base on the Darwin's theories, mean like if the number of human being they become very large, and then they start mutation, they start crossover to adapt with the environment, okay, and to make more diversity, to adapt with different kind of environments they live in. So for the data, exactly the same. So right now you can see like IoT right now they can give you a lot of way to collect data. So right now you can say that any time, any place, anytime, everywhere, you can say anything you make and you impact into the environment, so become the data. So that means like the data right now is very rich and very big. So right now we have like the big data, and also more about the advanced technologies and to create a lot of smart service to collect the data. And then they apply a lot of AI technologies into the equipment for smart service to collect the data. For example, you can see like, for example, like the Fitbit, yeah, the Fitbit. So that's such kind of examples of intelligent data, because the Fitbit, if you compare the newest version of the Fitbit and the first version of the Fitbit, you can see the difference, big gaps. Because the first version they give you only the raw data, okay, to go directly from your physiology, the data from your body, from your vein, from your sweat, okay, nothing else. But right now they can give you more. They can, okay, at least they can give you something about your sleep qualification, and also for your stats, and also they can give you some recommendations that how can you make exercise, or how many steps you should have for one day to improve your health qualifications. So that's kind of intelligent you can see. Okay, so the data right now, I think that's long time ago for the database people, data mining people, they work only for the raw data. There's not only the number of the character for images. They have no nothing. This a high level of semantics meaning. But right now you can see a lot of the data like that one. Okay, so we have two ways. The first one, the people they try to make a new equipment, a new service that they can extract the high level semantics of the data from the raw data at the place they collected. And the second one is they try to collect such kind of intelligence data and try to extract and to build higher levels. We used to say we have data, information, knowledge, wisdom, right? So right now we are in data, and then they have information. So try to get the knowledge and the wisdom from intelligent data. And that's where they come up with intelligent data analytics and retrieval. Okay, so what comes from the cross data? So you can see like here, I put a picture here. So the life is virtual. Okay, at the same, I mean like at the moment, you can, for each equipment of the data collector, they only see one piece of the virtual, or I mean like the piece of the picture. You cannot see the whole picture at the same time with only one or only few of the equipment data collector. So that's mean like if you try to understand the universal, like in right side here, if you want to see the universal at the whole, like the holistic view, you need to collect a lot of data from different kind of the sensor, right? So each sensor they come a different type of format of data, different kind of intelligence level of data or something like that one. So then now we come the cross of data. And that's what we want to do in this one. So now we have intelligent cross data, and then we try to get something like knowledge, something like, for example, like in astronaut, when you look in the sky, and for the normal people, you cannot see anything, right? But if you have knowledge also about astronaut astrology. So you can see, okay, this Scorpion stars, and or this one is the balance star or something. That's what we call the pattern, or some knowledge we can try to extract from the data. So that's motivations that we can set up the topic of intelligence, cross data analytic, and retrieval. So what? Okay, so now the data analytic, yes, you can understand, because analytic mean like try to extract useful information for your life, for human being. Retrievals mean like, okay, when you extract the data and then you store in your database or store in the cloud, so how can you retrieve the necessary informations in a sorted way? Okay. It's mean like we expect in the future, it's not type like you only type some keyword, and then you can retrieve something like the Google have done so far, but we can access in higher levels. Mean that we can change the way the people they ask the system to get back the future, back the answer. So that's the way of the topic going on. Okay, and then now we move to fundamental backgrounds. And here in my talks, and it involves several knowledge related to computer visions, machine learning, and data mining. So I just mentioned here about the computer visions that you can um, have something related to feature extractions, especially for retrain deep learning model feature extraction, and we have object detections from images. I mean, like show you the images and how you can recognize how many objects in appear in those images, and you name it. And scene detections mean like, okay, this picture captured in the park, or on the street, or inside the house, or in front of a restaurant, or something like that. So that we call it scene detection. And the last one for image retrieval is what it means like you have the data sets of images, right? And then you have one image. So you can say, okay, find me all of the images similar to the image I have here. So this is one very simple examples of image retrieval. The second one, like you can type the keyword, like, okay, find me a picture that one man stand in front of the dome in Tokyo at afternoon, for example, like. So that's a quite third kind of example of image retrieval, and the system need to answer you the picture that contain exactly what you describe about what you want to find. And for machine learning, mostly I'm talking about the prediction model, both for traditional machine learning, something like a super vector machine, or Bayesian classification, or deep learning as well. Okay. And then for accuracy measures, so we talk about the precision recall and F1 score. So that's something that relate to as my talk. And for data mining, I'm sorry about Professor Uday, because I'm just talking about your your expert. Okay, I mean, I talk about association rules, co-occurrency pattern, and utility-driven mining. Okay, in my talk. So that's some point of fundamental background that I hope that um, you can look at in the internet to get the idea about at the same time with when I presenting. Okay, so now is the main part of my talk today is what is the cross-data platform? It's when we Xdata PF is the idea come from. So exactly the ideas come from a long time ago. Is mean like I remember is the first ideas come up from our lab from 8 years ago. Parallel with the society defined by the Japan government. Okay, but the idea starts in this one. Okay, so if we have a lot of data. I mean, like at that time, we have some remote sensing data, like we have the IoT big data, and we have also live log data. Live log just mean like the data like they record frequently for a whole day, maybe 24/7. I mean, for example, like you can wear some camera in front of your chest, you go around and set automatically shutter a picture around 5-10 seconds once. So that you call a live log data. Even for, I mean, some log, when you log in is a log out of your computer, and they can call all of your activity when you interactive with your computer or your laptop. They also the part of a live log data. Okay, so assume that we have a lot of data from IoT, from another soft like remote sensing, and then we collect all of data, we integrate into our data set, and now we start cross data analytics. And after that, we can, from the knowledge or information extract from the cross data, and then we can do some predicts model or the data mining rules. And based on this one, so we can create some applications to serve for the human being, for example, like for smart environment, so smart sustainable mobility. A smart environment is something like the system you can give the people enough information about the place they want to go. For example, like people who want to jogging today, okay, at the park, maybe the system that can answer that, okay, it's not good at the park because they have a lot of barbecue, a lot of people there. So the risk of the air pollution is very high. So should you go another place, for example, like around the lake, instead of the park? So that's we call a smart environment system. And another smart sustainability mean like, okay, when you go out and you have bad weather, something like heavy rains, you have congestion accident in front of you, for example, like, and how the system can point you out, point you the way out with the optimal ways. It means like with less congestion, less risk of accident, and then less of air pollution, something like that. Okay, so that's kind of the idea at the beginning. We tried to put it across the platform, and then we go to Intel. So for the history, so the first one, the first step that we do, we call the event warehouse. It's not data warehouse at all because we say, okay, now we deal with the intelligent data. Okay, so events data in that state we call it intelligence. Because why? Because event data is the events detect from a lot of data. For example, like we say, okay, to which are the heavy rains. Okay, I mean like the big heavy rains. We can predict this one, so we call this one event. Another one, something like conjunction should be event. Okay, I mean like we store conjunction. We not store about the number of the car on the street, the density of the car on the streets or situation of the street, something like that. One that's draw data you can collect from the sensor installed along the street. Okay, so I mean how many car pass by that sensor per second. So that's one draw data. And we try to detect with we do a very simple model to detect some events, and then we store the event into our server and our database, not draw data. Okay, so and from all of events later, and then we try to find the association along of event amount of events. For example, okay, so what happened if what's the association between heavy rains, congestion, and accident? Could those things, if it happen at the same time for a long time, and then they can produce something like is harmful for the people, or how say it prevents the mobility of the people or not? Okay, and then based on this one, we can try to do the risk map. The risk map is what is the map? It's some kind of data visualization that we can visualize all of data to the user so that they can view by their own eyes that, okay, what happened now and what happened in the future, short future like 3 hours or long future like one day. So then they can have ability to give the decision by themselves. Okay, at this moment, we don't have any ability to give the recommendation for a user, but only so to be all of the necessary intelligent data, okay, in a different layer and different time and spatial temporal dimensions. So let the people they decide by themselves. Um, okay, so then the first platform, so we come up with this one. So and then we have three components. So we have the sensing data analytics. Okay, so this one is the first model that we try to extract the first layer of intelligent data directly from the raw data from at the place the sensor installed. And then we have spatial temporal data mining and visualization in the center of in NCT. And then we create a lot of API that can have people to create application for environments and health or and brainstorm and traffic. So in this case, we not directly give out the full applications because we not like the company to create the commercial products, but we give the platform and API. If you can think like if you use TensorFlow or Keras, okay, it means some kind of like this one. So we aim for create three kind of the services. The first one, we give the open source, and then you can download, you install in your place, and you can utilize your hardware and platform and to create the application by yourself. Meaning that all of the API, prediction function, everything there. So it depends on your hardware. If your hardware is perfect, okay, the application is run well. If your hardware very weak, okay, your application maybe have lag time or maybe not good in real time. The second direction has been like we provide you the service plus hardware and software like Microsoft Azure. It means like you can have the account, okay, and then you can access into the system. Okay, you can upload your data there. You can use all of the tool there. You can run and you can do your application and log back into your domain to create your website. Okay, so your website you can run like the REST API to send all of requests into the server and get back, and you can display in your own website. And the last one, we can give it like it's drag and drop friendly interface, like a Weka. If you familiar about this one, so the Weka, WEKA, developed by New Zealand or Australia University, and so that they give you a lot of functions, so very easy to use. Okay, it's not only code functions or drag and drop function, and you can create a new applications. And they have some tool to help you to change the parameter, and you can get back. But I mean like if you can, it's good for the student, okay, and or the people they're not expert in that area, so they're very fast. They can create some application for how to say to have the experiences by themselves before they move to further step, more higher technique or more expert. Okay, so the new results right now, you can see that we have, okay, so now we have the cloud, everything we put in the cloud, it's not in the server anymore. And then inside there, so we have a lot of, we can say we create the ETL, extract, transfer, and load. Okay, it's a kind of for the data system. And then we call the data loader. So we have ability to load the data from outside into our cloud. And then we collect the data, analyze, and we can have ability to predict some complex event by analyze a complex event. And then we can create a dynamic path and navigation. And all of those things here we create with API. So people that use that API, they can create some smart surface application. For example, they can create mobile applications, or they can create websites, or even they can create for a navigator that you can install in your car, okay, and you can drive along with the instructions. Okay, and here right now, so the scope of the data we expand now, not only weather and atmosphere, but we traffic, but we go to the health and the social network as well. How we focus for the wearable sensor and social network as well. Okay, so those things that we can move on this one. And this one is more detailed about how the new design is working. So we have the steps. So we need to loops, okay? So loop forever. I mean, like we have to collect data, discover the association among the data, and we train and use that knowledge, association knowledge, to train the model and to predict and send to the user the resource and get feedback from user, and then we train again. Okay, so we can look this one. So we can set kind of interactive AI, or we can say human-centered AI. So in like we not rely totally on the AI or the tool we develop, but we need to have the feedback from the user. And from that's why we have ability to personalize the model for each people. Okay, because you know that the human being is a very unique creature that we don't rely on other people. I mean, like we are unique. Okay, we're not look like another people. So we have your own behavior, your health, and your own character to recognize who you are, and that's also have you to personalize the model. Okay, and then this one is the overviews. Okay, and now we come up with this one, and all of the component we we have done and we want to do in the future. And also, okay, so you can see that underline is some sentence I underline, like this one. It's been like we want to do, we expect to do, and we expect to have the collaboration. We're looking for the collaboration to develop that part. Okay. And right now that we scratch, okay, at the beginning our system is centralized, but right now we start working on a distributed and collaborative platform. It's not centralized anymore. um, so we also pay attention for the private and private public data collaboration, um, because right now most of the data is come from, I mean, like a lot of data come from the private. Okay, so you can see like, you have a lot of wearable sensor, you have a lot of multimedia equipment, and you generate the data every day, every second, I can tell, and you can upload somewhere, everything that's belong to you. Okay, somehow like we can say like, if you, the more data you upload or you can share on the cyber space, I mean, the more naked you look like. Nobody, you cannot keep secret anymore. Okay, and then okay, so we focus for about machine learning, but for distributed machine learning and data mining, and then we have deal with a lot of sensing data. Okay, and we create smart cross data in the center. Okay, and then we have data collection, we have analysis technology, and we try to extract the effective information, and to then we turn the data into the value insight, and then we create application, not create, but we provide a tool to the people. They can create applications on movements and health uh, area domains. Of course, this one based on our experiences so far, on our data so far, we only aim for movement and health. But if you want to use our platform and you can do application for another domains, it's welcome, because that just platform. It totally depend on the data you feed on and the model you train it on, and based on this one, you can have your applications. So that's the new visions of the data platform, and how we can make it become a distributed and collaborative. So, okay, this is a little bit complicated here. Okay, so we have the platform here is the core. Okay, and now we start develop another one we call the cross data edge. It's a place that the first step of intelligence of the data can be extract. Okay, and for the cross data platform now they become some place that they integrate all of intelligent data extract from the cross data edge to detect something more wisdom, more knowledge, higher, very complex events or situation, higher level of semantic or intelligence. And cross the X here is totally local server. I mean, like, first of all, like you work like you have 5 organization. First of all, like you can work in different domain, and you have on your the data there, and you start collecting the data by yourselves. Okay, and then you can exchange. Okay, you can reuse the model create from the center. First of all, like federated learning, deep learning. I mean, like you can not you have ability to train the models in a distributed mode. Okay, so you use local data to train one weight here, and you send all of the weights into the center and retrain again, and you can generate the general, I mean, the over umbrella weights, and you distribute it again into the local. Okay, so that's when they continue like this one. So for the way that if we use across the edge and across the platform, so we can guarantee about the privacies, because we can say like, okay, it's not all of the user or participant they willing to share data or upload the data into the cross platform center, because private privacy preserving. They don't believe in us, because okay, who knows, maybe we can leak their data. So they can keep their data in their own server, okay, but only connect into the cross our center by via some protocol based on the platform. So in that case, that this the work very well. Okay, and this one we hope that for this one we can solve several problems of researching. For example, like the problem of deep learning right now has been like they rely a lot on the data. So what happens if we have a few data? So whether the deep learning can work on that one or not. Okay, so If we hope that, okay, we have a few data, but we have a lot of few data center like that one, so we become like the big one. Okay. So something like the bits of the big Buzzo. If you have a lot of bits of the Buzzo, so the ability to make the full images is better, right? Then you have few. So the thing of across the platform, and we can distribute and collaborate with another people. Okay. So how we can do that? This one, for example, like here, of course, we have a lot of tool, but okay, today I just really explain what I have done. Okay, the tool I create by myself with my colleague. It's not from another colleague. Of course, they have a lot, but we don't have time to explain everything. So here, I just try to explain something significant, important in our system. The first one is the raster image for drafting the cross data. So how you harmonize or you uniforms the data come from different sources in different format, and how they can talk together in the same rhythm. So this one for raster image for graphing across data. And then I explain about 3D CNN prediction models and a little bit, and also is in interview you the work I work with the person, Professor Uday Sang, to I'll say to sketch out the new direction of research. It's really interesting. And for image to API, it's mean like now we can say it's very simple equipment like smartphone. We can help the people to understand the evolution around them. Okay. And then we a little bit about the cluster S and MM sensing. So the extra component of cluster the platform. Okay. So the first one is the raster image for dropping cross data. Okay, this one for a big data in 2018, 3 years ago, 2 years ago. Um, so the idea is what? Okay, the motivation here. Okay, at that time we have the data like this one. We have weather data, we have accident data, we have traffic data, and we have the twist and Facebook data for a very rich data. Okay, and then we say okay. So we try to understand the association among these ones. Okay, if you understand the association among them, so if you know something, some factor, first of all, if you know the rules to associate those factors together, and then if you know three factor, and then you have ability to predict another factor, right? So that's why the motivation that how we can do that one. But the point of this one, the accident data, weather, traffic, and accident, they come from different resources, and they come from different formats, totally different in spatial temporal dimensions. Even they don't align or they don't exist together. So how we can work with those data like that? And this is a problem statement. Okay, so we have everything is the time series data. So we have a set of factor. Okay, and then so whether we can have the model to detect one factor based on the rest of factor. The point of this one, we don't know how many factor is enough. For example, you have 10 factors, but how many factor is optimal for you to collect and to predict another factor? And whether or not that, for example, like you have, okay, your model trained with three factor, but suddenly one factor they disappear or because they have error, failures or broken, and then whether we can pick another factor to put into the model and to keep the model run again with acceptable accuracy. So that is the question. And that's very similar for the IoT area. So you can install in your house a lot of sensor and use all of the data come from that sensor to predict something. For example, you detect that you forget to turn off the light, for example, like. But what happens if one or two sensor is suddenly broken? Is still have the model strong enough to rely on the rest factor or sensor to predict or not? So that's some question we try to answer here. Okay, so the approach to this one, okay, and instead of we analyze data independently and or to try to find a correlation among them, we usually to process them into uh, one space. Okay, so mean like we try to process them into one image. We go with a different layer, a lot of layer. We call it raster images. And then when you have the images like this one, And then definitely you can apply the computer vision and deep learning and to detect something from the image. Because right now, you know that the deep learning mostly the focus for computer vision and natural language processing. Okay, so they have a lot of milestone, significant milestone on understanding the content of the images. So that's why when we turn everything into the image, so we can utilize everything from the computer vision and deep learning, and for classification, for object detection, or uh, for prediction something. Okay, so that's my strategy. So the idea is very easy, very simple. Okay, in the map of Japan, you have mascots. So I mean like this area around 200 met plus 200 met, like this one, and they have the GPS and ID. Okay, so if you work on the geography on the Japan, you can know it's very common. So instead of we sit, okay, now we can use, okay, we use the super pixels. So if you work in images, you know that, okay, what is pixels? Okay, pixel is one dots that can have information about the color or brightness or texture or something like. The whole pixel, they put them together, they become the image. So right now we got super pixel because this one really big, not only one dot, but like 250 and plus 250. So, okay, so you can see this one. Okay, based on the Liloff, and then you can see the different color here. That's the values of the factor happening in this area. First of all, if you say, okay, here I talk about the heavy rain of conjection. Okay, so this for X mascot, you have the nature of the conjection, I mean like the conjection length. So the color of the area here is may be changed along with the density of the conjections. Okay, so the dark color is very the dark color is very conjection, and the light color means no, it's normal, it's no conjection. So we have this area is a very high conjection in this area, and you look at this one. So the idea means like, okay, instead of we work directly with the numeric time series data of the conjection, why not we change into the image like this one? So all the map here you can turn into the pixel like this one, and then you can turn like this one. Okay, and you can see that here. Okay, this one snapshot. Okay, this one rain informations. So you can see this one is very, how to say, it's very heavy rain in this area, and this one light rain. And the conjections, okay, this area is very high conjection, and this SNS mean like the people are talking about a conjection accident or the bad weather. Okay, this one. So you can see this one for X mascot here, they have several layer of data, right? So what happens if we superimpose, we put layer on a layer. So when you put three layers together here, and you can generate the GRP image, red, green, blue. Okay, so now we say, okay, this one become red channel, this one become blue channel, this one become red channel, and we put them together, and then you have the image, new images. So this image, we draft the data into one space, okay, one spatial space at one time. And then you can see, okay, now you look, if you superimpose this image into the map, the real map, you can see like, okay, this one is something like, okay, this one maybe heavy rains and conjection at the same time here, for example, like that. And then you try to understand the pattern of these images. Okay, so you can see that what happened here to try to understand. And then for example, like if you have the big picture like this one, and you say, okay, this picture is for a representative or assign a label for the heavy rain, and the conjunction happened when heavy rain happened. So if you train in this one for a while, and then you have ability, if in the future some picture like this one happen again, and then you can very easy to say, okay, this picture they already happened, and it look like in the training sample, and then they should be the conjections. Okay, so that's the way we do. And this was spatial. So what happened if you put along the time? If you put the along the time, and then you can turn all your data into the video. Okay, so they become the 3D video. Okay, this one, if you work in the video, you can say this one frame. You mean like one image captured in 1 second, for example, like. So this one next second, if you align this one in for the time, and when you play back, they move in like the video. Okay, and so now you have the video, and if you want to try to understand or analyze the content of the data of the data video, you can use video tune in the computer visions and the deep learning to understand that one. For simulate, you can detect a trajectory. So from this one, so you can, if you apply the trajectory detection on the conjection, and then you can see the trace of the conjection happen during the time of a heavy rain for simulate. So that means like you have ability to predict that's whether if the congestion happen and then in the future how long they will reach and how large they can spread into the area, and if they have it continue like that one. Okay, so then you can see like, okay, to have, okay, this one how we can apply, and it's actually very simple for VCC 16 model, or you can use the super vector machine classification, right? But here, the original images here and reset into to 224 pixels, and I put into the VCC, and then we can have this one, or the output of this one. So this is kind of output for training. So if you look here, sort of softmax here, you can see, okay, whether this image should be have a conjection or not, if the having it happen or something like. Okay, so that how we can detect the relative accident risk area detection. Okay, so this way, my model is not detect the accident. The accident is really difficult to detect, but I can say like, okay, our system can give the alert about the relative accident risk area. It means like, oh, that area they have how many percent the accident could be happen. Okay, if the situation continue like that one for a while. So then here I have this one, for example, this one experiences or in the Kobe. So when it happens, so we can locate some area that they have very high relative accident risks when having heavy rain happen. So based on the result here, so you have ability to alarm the people that, okay, please avoid this area, don't go inside that area, because anyway, you will have the very high risk to get accident. Okay, so that the outputs of the cross the intelligent cross the data analytics. And this is one example here. So the one I run, I mean like I run from the real data here. So you can see like we can spot a lot of point about the area of the Kobe area. So this one is the route along the Kobe Bay. Okay, you can see that along the time. So you can see the time here. So this one is the situation happened when the Typhoon Nangka, they attacked Kobe in 2015. Okay. And then here the update rate is 5 minutes. Okay, so I turn 5 minutes into 1 second here to soften the time. And you can see that we have ability to point out which area with the very highest, with the red color, very highest place of the accident, and blue the lowest, green and medium. So you can see, okay, now you can, this one the rain happen here. So then you can say that they move in. Okay, this one the rain, they move in from the west into the east. And then you can see the situation of the accident. They also move along with the heavy rain. Okay, they start from here into here, and then also heavy rain, they start like this one. So it's good, right? So that's how we can say our system we can do about that. Okay, so this one that how we can use for the 3D. Okay, for 3D, this one, the future we want to do in the future. It's not yet, but we try to see whether we can apply the 3D raster images. I mean that for the timeline. And this area, the 3D has been like along with the heavy rain, and then we can detect something interesting or not, and then we can use this one for the time rule or Axelson mining here. I certainly get this one like the open topics, and if you're interested, you can do contact me. And now we move to another one for the 3D CNN prediction models. Okay, so the result here I use only 2D. Okay, lastly, so what happened if we use the 3D? Okay, how to do this one, and how we can discover the pattern in and predict the conjection. So this one is very interesting later, but a little bit it's very easy to make the people confused because the idea is really new, and we also have a very beginning resource about that. Okay, I'd like to introduce you this one. This work we work with the Uday-san, Professor Uday. So the idea is what exactly the same. Okay. Now we have the data from social network, weather, accident projections, and then now we have the intelligent transport system. What we want to do? They consume all data here and they try to predict or they try to extract the pattern. And the output of prediction of the conjunction or accident and the pattern, I mean, like the relationship between our factor together, where they can have the people to enhance the safety when moving. Okay? So that's the targets of the research. But how about the conventional people they work so far? Okay, they work so far, usually they look back in historical data. Okay, the first one, you need to have the historical data. I mean, like your experience, I mean, like you learn from experience. I mean, like you learn everything from data and you create the pattern, you create the model, and then you predict in the future. What happened in the future, short term, medium term, and long term. Okay, so you predict, okay, you say 3 hour like next, and then you have a conjunction in that area, or one day next they have accident in this area, or 3 days after. Okay, so that's the traditional way they do. Or what happens if we do in another way? We do everything in the future. Okay, so I mean like, okay, so now I'm current time. I look back a little bit about the historical data, and I predict in the short term. Okay, and now I have the new status here. And I use the predicted data and like historical data, and I predict for the next step. And I continue this one in totally in the future. Of course, the accuracies when you predict is not compared with you work in the historical data because it already happened and you confirm about right or wrong. But here you only prediction. It means like you have uncertain probability data here. Okay, but no problem. Think of this one. Okay, if you have ability to predict like this one, and then when you collect all of the data, predicted data, and you apply data mining to mine set kind of data. So what pattern you can discover in the future? So that's a question. I think like, okay, so if I hope that I can discover some pattern or some rules in the future, that's good because okay, that the rule happened like this one. So definitely like if I have the rules and a periodic happen, and then I have ability to prepare the plane to cope with that situation, right? You have a lot of time. The point of this one was what is traditional and future. A traditional here, traditional that you can say, okay, and they can predict exactly the time. Okay, that time, what happened? Okay. But here we say, okay, and that time, not only what happened, but how they happened. Okay, so what happened and how they happen, so we can know why. So when if you, it's in a smart way that if you trade backs in this different back here, and you can choose which current time that you can need to interfere and to stop. Okay, because maybe you interfere too early or too late. If you say, if you predict, okay, as I say, 3 hours in that place will be conjunction, and then you don't know, okay, which time from now, 1, 2, 3 hours from now, which time I need to interfere. I mean, like for the police, chat box police to interfere in that area and to prevent something happen the next 3 hours. A quick kind of approach like this one. So when you predict something, you can try back and you can say, okay, which play you can see picture here, which time does we can need to interfere and to prevent the significant breakout of the conjunction or something like that. It's very good, right? So the idea is easy. I just try to use the previous resource that you know about this one, wrap data first, okay, and to fuse all of the information here and to predict, okay, we need to predict the first, okay, we need to predict for future step. We predict, okay, the future, 1 hour, 2 hour, 3 hour later, and an hour later, what happened? And then we apply this one for called maximum periodic frequent patterns. It's developed by Professor Uday. It means like we try to find the rules or the pattern of the predicted conjunction data. So we can try to find the rules or the pattern among them. And I mean like, so we can try to find the longest conjunction they can happen in the future based on the detection of the future. So when we know the longest happen, and also we know when they start have maintain start have very dense congestion in that area. So we can decide that, okay, what time we need to interfere into that area and to stop the congestion, and don't want to let them happen for a long time like that. So now it's very easy to combine two methods together. The first one, you need to predict, okay, the conjections in the future, and then you pass this one into the model of the Uday processor sensei, and then you can have the max periodic frequent pattern, and you can have the longest patterns of the conjections in the future. And when you have this one, so you can locate in the map and you say, okay, that happened is very frequently in this area. So it's good not only for the transportation police, also for the people moving on that area, but also for the urban management. And mean like because okay, in the future that okay, that area they still have at that time after 3 hour raining, and usually they have congestion in that area. So they should have something in urban construction to change or to modify or to convert that area into something else to prevent that frequently happen, or periodic happen heavy rain or congestion in that area. And this one a little bit about the comparisons of the results about how accuracies and how fast the method that can work. So you can read the paper, and I want to go deep inside in detail in this part. Okay, so what does the pattern future traffic look like? Okay, so then you can see the one example, like you can see, you know that okay, if we run different okay a day every day like this one, and then we can collect all the pattern we have. So sometime that we can recognize okay, this area and this area they usually after 5 hours from the starting raining, after 5 hours that there should be a whole area they have a congestion like that one, and this area no matter what in between here they have congestion or not, but definitely at 5 hours later and 10 hours later they usually have a congestion like that one. So if you look like this one, if you are urban management, you have the planner, housing traveling planner, so it's very good for you to handle the situation, right? Okay, and also like this one, you can see that one like I mentioned. Okay, so I know like when I try back, and like I said, the situation of 1, 0, 5, 10, 25 hours later. Okay, so you can see like okay, from now on it's just only from 0 to 5, they just suddenly very high. Okay, the steep high here, and within 5 hours, this one they jump off into very heavy congestion here, and then start slope down, so some love down like this one. So when you look back in the situation on this one, so okay, you need to decide, okay, you need to interfere right after the event happened in this area. Don't wait until the 5. Or if you are the working or you normal, like you are a traveler, normal traveler, so you need to wait until 5 hours. Okay, after 5 hours, now you start moving so you can escape this area for the I'll say for the conjections. So this one ability you only give you when you work with the predicted conjection. If you work with historical data, you cannot do like this one. You don't have ability to have such kind of knowledge like that. Okay, so this one is for the newest research. We call the image to AQI. It's mean like the idea is very simple. The question is mean like whether you can use smartphone capture several few images around you, and finally you can know the air pollution, air qualify index at your place. Mean like the PM2.5 is really good for your health or not good for your health. That's the idea of the application. So the idea of this one, so we start the motivation for the media eval. It's mean like we call insights for well-being, impact of for environments on human daily activities. So this one we say okay, here you can see the right hand side the picture when you stay at home. When you decide to go out, how many questions you need to raise by yourself, you need to answer by yourself before you decide to go out. I mean like go out for relax, for doing exercise, not for going work on supermarket, something like okay. I mean like you go out or not is also still okay. So mean like you need to ask, okay, when I can go out. It's sunny day or windy day or cold day, or I mean like with whom I can go. Can I go out with I can meet my friend at the jogging path, and I mean the whole I mean like my situation of health is good for me to jog in for 3 hours now, or only 1 hour is enough. Something like that's one. So they need to have the answer. So the question, I mean, like whether we have ability to answer such kind of these questions uh, before helping people to go out by using the data from the urban perceptions, from air pollution, weather, from live log. Okay, a live log mean like the picture you capture along a long way, or you can say like all of the picture that goes into the social network capture at the same place. We can say that's a live log. I mean like the log of the life. Okay, so I mean like a lot of people they capture the picture or they write something in a social network and report the situation of that area. But we collect from the crowdsourcing from a lot of people and they update every day, right? So we have the full historical of that area for every day. So we call it live log. For the urban perception is what? I mean, like we analyze the data of the images. We know, okay, that's a green place, or the park, or dark place, or the vehicle place, or something. That's one we call the urban perception. It's dirty or not, the cleanliness or not, the greenness or not. And evolution, yep, you can use this one from public station. You can access some website that can give you a lot of data. But the point of this one, the data here is not precisely because we have few stations installed all over the city. Okay, so if you stay nearby the station, yeah, you can get very precise values of the evolution. But if you stay far away from a station, and the result is not precise because the station cannot reach at your area. And how we know about like this one? Okay, so that's the point. And then now we raise a three hypotheses based on long time we observe the data. Okay, the hypothesis one is if a set of surrounding environment images which were captured repeatedly and continuously in the same place at the same periods share a typical AQI level for a significant ratio. So a few images captured in same place and period, but in a short future could probably share the same typical AQI level. Okay, so mean like we can say, okay, the scenario will not change today and tomorrow, almost similar, right? So I mean, okay, if your place, for example, if your place is very clean for a long time, and every day I measure the AQI is exactly the same, it's very good. So I mean like they tend to be good, except they have some anomaly happen. Okay, so that's that area. So that hypothesis mean like, okay, if not if don't have any abnormals or anomaly, so the situation will be maintained at that place for a long time. Because if that place nearby the factory, they have a very high AQI level, so that's still very high AQI level until until the days that the factory is shutting down or they do something else. If not, they still like this one. That's the place. Okay, you can see the right hand side. You can see that pattern. Okay, the pattern for the same route at the morning and the noon and the evenings. You can see the mostly like the area not change. It's not changed at all. I mean the AQI very high in this area and it's still high in this area from morning, noon, and evening. There's some abnormally they happen something due to some very particular reasons. It's rarely. So this one that's for hypothesis. So I mean like the idea mean like okay if you have a historical data of AQI of that area, so you can say very simple, okay, tomorrow should be the same or a little bit change. It's not change much. The hypothesis two is what? Okay, the fluctuation of AQI level at a particular place could probably correlate to abnormal activities or events. Okay, so mean like you can see here. So normally this display is the AQI very low, but suddenly one day they have construction sites. Okay, so they digging out the basement and they do something here. So a lot of dirt and everything have vapors into the air. So that's why the cause of the AQI level. So I mean like if we have ability to detect some abnormally happen in that area, so we can link the question, okay, that abnormal event happened there. It could be the causality of higher AQI or lower AQI. So then here we need to base on urban nature. So when you look at in the picture and then you can detect, okay, this is the dirty place. Okay, this is dirty place based on urban nature. And then you can say, okay, this abnormal here comparing with the green or cleanest place of the historical data images. And then there should be the abnormal event here. And then the AQI should be in gray. So in this case that we not try to detect the exactly value of AQI, but we try to detect the changing of the AQI from normal to higher or from higher to normal, something like that. Okay, so based on something that we can recognize from the images. And hypothesis 3, it means like there could probably be the set of visual feature, okay, both raw and high semantic level extracted from images correlated to urban nature, like park, street, lake, and surrounding environment sensing later the API. Okay, first of all, here you can see. Okay, so we have a sensor box here. The sensor box here has been like that's the API, PM2.5 temperature, a lot of here. And also we have light log camera in the picture capture in this area. And when you analyzing the picture by scene detection or by visual feature, something like you can recognize some tree, some green nuts, some cloud, some smoke, some leaves, something like that one. So those point, those high semantic level that feature that can give you the cue to understand the situation of the events happen in this area, correlation to another social network, and also correlation here. So you can see that very tight. Right here they have the barbecue food court, barbecue festival in the park. And then we have to see a lot of smoke here, people here. So I mean like this, normally the park is very low AQI, but in this abnormal, so we have a lot of smoke here, a lot of crowded people here. And we also have the confirm about the events of doing something related to air pollutions. And then that should be the resource for changing the AQI from low to high, okay, like this one. So that's a hypothesis 3. So based on 3 hypotheses here, we can use the model to use image to detect AQI. Okay, not precisely AQI, but the fluctuation of AQI. The first one we use very simple. It's the image retrieval. I mean, like just compare. Okay, we take a picture from that place at a new moment. I mean, like today I take picture and I query the picture to see which picture in database it look like with that image with the condition constraints about the locations and time. I mean, that should not be over longer than 7 days. After 7 days, we know we don't know. It should be the situation different. We assume that within 7 days, the situation should be the same. Okay. And today we capture the images and we look back into 7 days and we look at what images capture in nearby that place, not another place, nearby that place. And if we find the most similar images with the query images, and we can capture, we can get the AQI of that image to assign here, and then we can detect the AQI at this place, right? So if we cannot find any similar images with that images, I mean like they have something abnormal happen, because we know that our image only captured in this area, but this images they have different with another one. So then we go deep inside. Now we need to understand what happened in that images. And we try to detect some abnormal. And then we can say, okay, this AQI should be higher or should be lower. So that's the way we do. Okay, so this one, learning data collection, you can have a lot of images. A lot of images we have, we collect in internet, or we can ask people, they can wear the camera, they can go around. So actually we create the historical data, a lot of the image database by asking some volunteer to query in the camera to go around the city for 3 months. So that's enough data for to doing the in-lab experiences. And we use very the fast, okay? The fast is mean like the billion scale similarity search with GPU developed by Facebook, okay? Because we have a lot, okay? We have a lot of images, and one X image we have a lot. The visual feature is very huge. The dimension is very large, so we have a billion parameter. So it's a good one for this one. So the idea is very easy. Is put the image, capture the image, put into the fair, and to look in the most similar and get the AQI from that similar image to assign to the current image, and you get the AQI. If you cannot find any similar images, mean like for threshold, then you go back and to analyze the data, the images to see I'll check another source of the data like social network, or check for public data about air pollution or the weather, and to conclude, okay, that AQI should be higher and lower comparing with yesterday or the day before yesterday. Okay, so we can have properly, you can give the people the level of AQI, okay, like AQI good, not good for your health, or something like that. So that's the research of this one. Um, so here we test the idea with different feature, visual feature, FixRec, faster RCNN, SCWAV, and with different data sets. Okay, with Tokyo data set, Ho Chi Minh City, Vietnam data set, and India data set. So there are three different data sets. They have three different characteristics. The vision air, they focus only for sky in sense, mean like they focus for the color of the sky and the smoke. So the hypothesis mean like the more smoke they have in the skies, the more air pollution they have in that area. So that the hypothesis they build for their model. So that's why their model they only focus for analyze the entropy of the images to get all the fields of feature relate to the smoke level, and then they link that smoke level into the AQI level. For the Tokyo images, that mean like we more urban nature than, because why you all of the image capture from the first view of people wearing camera here, they capture here. So the angle of the image is very narrow, so it almost down on the street. And we also use extra data from street view and social network. They capture around the street. So this one we need to pay more attention about the urban nature than the sky, because we don't have much information about sky. So nature mean like, so I would try to find some cue for small like density of vehicle, the greenest zones, and something relate like this one, and to see, okay, this one is the high or low AQI. And for Ho Chi Minh City, mean like they on street instant because they go along. And you know the Ho Chi Minh City in Vietnam, they very famous about motorbike. A lot of motorbike, and they can produce a lot of smoke. So in this case, that based on the density of the people traveling on the street, so they can measure the AQI. So they can link the picture capture from image from on street, so they can count the object moving on the street, and they link into the AQI level. So that's the people they do like this one. But when we apply our methods in very simple way, like I just explained to you, so you can say the accuracy is acceptable. It's normally higher than 80%. Okay, 80%. That's only the beginnings. I mean, like we can confirm that our hypothesis is very good, and now we can think about we can apply new model about deep learning or more complex, more complicated machine learning to improve the accuracies here. Can we can okay. So in this case, I mean like we can turn the image, normal image, into intelligent image. I mean like that image can tell you something relating to the surrounding area. Okay, and then when you cross that intelligent image into the public air pollution data and social network and the weather, and then you have more cue to understand more intelligent of the data, and you can have very precise or high accuracy prediction in the future. So that's the way we can do with intelligent cross data analytics. And this one, based on this one here, we can use all of these algorithm and model I introduced you so far. We already create like the API, and that's very easy to call via the REST API. And you can create new application by using calling these API, and you can create a new application on a smartphone and to capture the image and to see API automatically in your phone by yourself. It's very easy. We also lower the manual instructions about how to use the cross-data platform on the internet. Everybody can access to see which the list of API we provide and how to use that one, how to code the function, how to programming with the API. Okay, a little bit about visual feature. Why I decided to use some feature of this one is totally depends on the hypothesis I introduced, because some feature they focus to capture some object. Okay, like faster CRNN, they detect some objects, right? Maybe try to like building vehicle, tree, sky, clouds, and those things like very suitable for Tokyo Data Olympic because we focus for the urban nature to find a relation between the urban nature into the AQI. And then for the fixed rates, and also for the SWIV, so the unsupervised learning. It's good when we use this feature when we try to detect some AQI by image capture at the place we never have the data before. Okay, so that's good for this one. But as long as okay, this landscape look like some lake we capture in the past, it's okay, but not exactly the same location. But that feature is very good. That's the reason why I choose. That's the reason. Of course, we have a lot of visual feature in the market right now, but depends on the hypothesis and your purpose and your model. You can choose which one is best for your model. And this one is about how we can deploy socially across the platform into applications. Okay, there's some application we already do, and we are still checking in Chiba Sea. And soon, I think like when we can get approved from the city hall, and then this one they can launch in the public, so everybody they can use and to do. So we can predict we call the multimodal air qualification prediction, and we can we predict in this one and report it in the map, and the people they can use mobile phone to access the map, and you can see okay roughly the air qualification at that area within 3 hour or 4 hour look like how it's look like. Mostly this one they based on the transporter. I mean like they detect the air pollutions in Japan depending on the air pollution level and the wind direction from the mainland China into Japan. To have the people in the west side of the Japan have really have enough time to prepare to cope with the air pollution coming from the mainland China. And this one, another one is we say about the environment beautification for everyone. It's been like uh, uh, to avoid dirty and UV and air pollution in urban city. Okay, so based on the live log camera or smart camera or the social network people capture, so we have ability to detect okay this corner is dirty or not, which is greener or not, and also we create a map for this one, the map in Milan, you can see the color dark red here. It means that area is very dirty and also very air pollution is very high. So if the people in that area they not keep clean for that area, so they still have dirty and very high air pollution. So the market here very red. So the tourists and the people they reluctantly to go in this area. So all of the active tourist activity in this area will be die soon. So if the people they want to attract people to come to this area, they need to clean the area. So this means that we have to cooperate to clean. So, okay, the resident and local government they make collaboration together and to start into the business economic profit. Okay, if you don't clean your place, you don't have no money. So this application they can do like that one. Another one is for smart sustainable mobility. Okay, so you can say uh, or we can say like okay if have read based on the CRNN or CDCNN model I introduced you just before. So when the drain in here, so we have ability to find the routes. Okay, the routes like which route from here to here. Which route is good? Okay, the shortest route, the safe route, or the risk-free route, depending on the risk model. And also another one is for the joking people. Okay, so whether they run around the city, which routes are good for them is to avoid as much air pollution and UV as possible. So they can slow down, and the people they can run with the routes we chose for them. That's good, right? Okay, when you use application we on across the platform. Um, and also for smart comfortable tourism. Okay, this is for long term. Like this one for relate to the research I interview you with, I work with Professor Uday Sensei about how we can predict something in the future. We can discover precisely the time, what happened in the future and the rules happen in the future. So this is good for making a plan for the people, right? So before going out for traveling, so they can have a plan they prepare, record, share, and select around this one. So all of the model here, they can build application around them and to give people enough information about what happened in the place they want to go. For example, if they want to go Nagano in this next week, and the system should have ability to give them, okay, which kind of the glove you should wear, which kind of transportation you should take, avoid to take the car because highway will be frozen, or you need to go by airplane or by train or something like that one. So that's the point that we can apply across the platform into social deployment like that. But this one we're still working on this area. Is we still a lot of things to do. This one is the result from Uday Sensei. Okay, this one we could try to use draining data and to try to detect the conjunctions in real time. So you can see that the result from Uday-san to he applied data mining knowledge, and all of the point here is it happens in the future. But the point of this one is, like I mentioned before, like there's no way that they can predict, but they don't know precisely how when they happen 3 hours, 4 hours, and how they evolving along the time. So that's the way we have for to show in the future. Okay, so this one is like the safe route navigation, and you can see like, okay, so those information that we can update online. Okay, so which route you can go. Okay, you can see this area it's raining down, very heavy rain here. And the red here means like the softer routes, but you need to go through the area of heavy rain, a lot of conduction and something risk here. And this one is risk free. Okay, so and also here, and ability that you have ability to change the routes in the video. I mean, like the system, they have ability to not give you the offline prediction at the beginning, but during the route, they can give you another recommendation to change the route if you want to change. So that's how they work, about using the cross-data platform and to do the safe routes navigation like that. Okay, and last but not least is like we try to remote the cross the platform to ASEAN IVO project. Okay, so like right now we provide across the platform into the five participants, and then they will reuse the cross the platform to develop their own application using their own data. So they usually like create the application by themselves using the API provided by across the platform. And this one for building application. For research, we also have a collaboration to develop new models, prediction model or associated through discovery pattern to the new domains. For example, like now we start working with the dengue disease to have ability to have people to prevent um, the propagations of dengue when the dengue outbreak, something like that. Yeah, so that's the point we do, and you can look back, you can look for the detail of the process in this link. And we also have the ICMR workshop. So this year is the second one. So you can access in this area. And if you have some paper or research, you can you are welcome to submit into this one. So we in this workshop we try to promote the idea of intelligent cross the analytics and the TFO. So whatever you think in your mind about a solution, algorithm, or applications or new domains, you can try and you can submit here. I think that's a good forum for us to share in and to discuss with the same common sense that we can hope work together. And this one for Media Evolve. So this one is you can look into the link here. We organize the task they call insights for well-being. The task like something like this one. We give you the data set, okay, the gross data set, a lot of data from different sources, and some questions, and you need to find a solution for that questions. Okay, and you send back the result. Usually we release the data for 3 months. So during 3 months, you try to find the solution, and then you send back the result into the organizer, and we ranking and we say, okay, we give the prize for the best result and also the best idea. Maybe the idea your solution is not yet the high accuracy, but the idea is really the breakthrough, and I mean like give the new perspective about the problem. I should be welcome about that. So I think this area is good for this forum is good for us for challenge ourselves and also sharing the solution among them among us. And also from this year, we last year this one we organized 2 years so far, but two last year we only provide the data set and the baseline and the questions and the people they need to answer the questions and compare with the baseline and you the provide data. But this year we intend to release our across the platform. I mean, like asking the people to use across the platform use their own local data and to create a new applications. Okay, and then we will give the prize for the best applications ever based on this one. And after that, we can have more further collaboration with that group and to make the application become like the fulfill. Maybe it can turn into the market or something like that. Um, okay. As just case, I'm at the time is coming to the end. So the conclusion. So today I'm very happy to introduce you for about the cross the platform and its components developed by our lab. And we also still looking for the collaboration because we, as you see, that we have a lot of things to do, not only for machine learning or data mining, but also for private public data collaborations and for working with IoT and also working with event detections or something like that one a lot. And also for privacy as well. We also pay attention to privacy. Um, and also to create the platform and good platform. And I mentioned before that we tried to create three versions of the platform, like open source, the services, and the bucket. Okay, so which one is good for which people we don't know yet, but we that's why we ask that whether you're interesting, you can ask for joining the process, so we can you can become like a tester and to use the service, and you can give us a feedback. Okay. Yeah. So okay, so I think that that's all my talk today, and well, thank you for your attention, and that's all. So if you this one is the contact address, so you are welcome to contact me, or you can contact any member in our lab and put the link here. Okay, thank you.
Thank you, Dawson, for your excellent talk. Yeah, actually, two professors have joined and listened to your work. One is Trang Sensei. Trang
Yeah.
Sensei, are you here?
Uh,
I think he just now left for the meeting.
okay.
Okay, but there was one more Watanabe Sensei, so they left for the meeting. We had a meeting now, so
Mm,
they left. They wanted to inform that it was a nice talk.
yeah.
Thank you very much. So now, Dao Sensei, the students who are now here are my
Mm,
students. I
okay.
will introduce you to them. So,
Mm,
students, please open your video so Dao Sensei can see you. Yeah. So I will start with the senior most person, my PhD student, who is
mm-hmm.
Ravi. Ravi, are you here? Yeah.
Hello, sir.
So
Good
he is
evening.
Ravi. Say hi to Dao. So
Okay.
Hi,
Hello.
Sensei.
yeah.
Hi,
So
Sensei. Good evening. This is Ravi Kumar. Okay, have come from India. So
Mm-hmm.
currently, I'm working as a PhD scholar under Professor Uday Sensei, and I have completed my master's from Indian Institute of Science, Bangalore.
Mm-hmm.
After that, I worked as an assistant professor in my India, in my country.
Mm-hmm.
And at present, I'm working here, sir. So under Professor Ravi Uday Sensei
Yeah.
in the field of association rule mining.
Mm.
So it is very nice talk to It is very nice talk, sir.
Okay.
I've seen a lot of applications just now in your
Mm-hmm.
presentation, so which are related to my field. So it is
Yeah.
something like pollution data I have seen, and
Mm-hmm.
congestion data also I have seen that.
Mm-hmm.
So some good applications you have introduced. So thank you for the talks.
Okay. Thank you.
he will be coming to NICT also along with me. because he
Mm.
needs to work on data sets, right?
Yeah.
He will be here. And next one is Narendra. So he's from India. He's
Mm.
my supervisor's student or my junior. Narendra, are you here? So actually, I was planning to bring him to NICT when I was there.
Mm.
I could not bring him, but this year I am planning to bring him. So he's
Okay.
here. No. Then according to senior, next is Saideep. So the gem. So one of the best student I had in my life is Saideep. Saideep, are you here? But now he is went into hibernation due to COVID. He has to come back to his farm. Saideep, are you here? No, I think they are not here. So after Saideep, then comes Pradeep. Pradeep, are you here?
Yes, sir, I'm here. But my video is not working, so
Okay, so Pradeep, he works in high utility mining. So he is
Mm.
the one who developed the spatial high utility item set miner.
Oh,
So
that's
yeah,
nice. Yeah.
so he is the one who developed it. Saideep works mostly in periodic pattern mining and parallelization.
Mm.
That was his
Yeah.
work. So after Pradeep comes Likita. So Likita is not here. Likita, are you here?
Yes, sir.
Okay, yeah. So she also works on pattern mining. So she is the
Mm.
one who published the paper in IEEE Big Data along with me. Now,
Oh,
yeah. So,
nice.
so now
Yeah.
we have sent, yeah. She is sent two more papers to DASWA
Mm.
and then to PAKDD. So Saideep is working on binary form of data, whereas Likita will be
Mm.
working on uncertain data, the one that I
Oh,
showed it to you. So you have
okay.
asked the work, right? So she is the one who did everything.
Mm.
So
That's
I am,
nice.
so she is Likita. So Likita, this is the first time you are seeing, right? Because we have
Yes.
simply added him in the paper. You haven't met him. So he is Taosan. He also worked as a professor in Brunei. Then he moved to Japan.
Okay, sir.
Then comes one of, yeah, then comes Sai Chitra. Yeah, so Chitra is here. So she is writing her paper now to IEA.
Mm.
Actually, Dawson, Chitra, are you here? No.
Yes, sir.
Yeah, she is here. Good. So what happened is, previous year I have submitted my paper to, I have paper in SSDBM, right?
Mm-hmm.
So she has developed the faster algorithm, which
Oh,
is order of magnitude faster than us, than mine.
cool. Yeah.
Order of
It's
magnitude.
really
It was
nice.
so
Yeah.
fast, yeah. So
Yeah.
we tried to send it to EDBT, but
Mm-hmm.
we could not make it because we did not have enough time,
Oh.
and I was unable to get the proper things. So we
Mm.
could not make it to EDBT. So we are now
Mm.
converting it to IEA. But I am
Mm.
planning to send it to a good journal, A star
Oh.
journal, because her work
Mm-hmm.
demands it. So she has done excellent work. So that is Chitra. So these are
Mm.
from India. Now I will be introducing you to my students in Aizu
Mm.
Daigaku. So students of Aizu Daigaku Big Data Group, please open up your cameras. So the first person who joined me is Kazuki. So I will introduce with Kazuki. Is he here? Kazuki-san? Arimasu ka? Nine. Okay, he is not here. But he will be working on graphs. I told you, right? We will be working
Mm.
on
Yeah.
graph mining and graph prediction. So he
Oh.
will be the one who will be working on it. Then
Mm.
these are the two new students. So one is Nakamura-san. Say hi to
Hi.
Tao-san. And another one is Yudai Masu-san. So
Right.
these are Japanese students of Aizu Daigaku. They have started learning data mining.
Yeah.
So they have written the code for a priori.
Okay.
Yeah. So
It's
Nakamura-san
very
has written the code which is better than mine. It was faster.
very
So
good.
Ravi has evaluated it and he said, sir, it
Mm.
is faster than ours. So it's
Mm.
good. So these are the people in our team. So
Mm.
mostly you will be seeing Nakamura-san, then Kazuki-san and Yudai Masu-san regularly. So
Hmm.
these two will be working on periodic pattern mining.
Oh,
So students, you have listened to Daosan's presentation, right? So any doubts or any questions? No doubts? No, you can open up your mics. You can talk freely. Any, oh my God. Okay. It's better to keep mute. So any doubts?
No.
Okay. Dawson, if students want to work on X data platform, what should they have to do?
um, actually, we need to ask Jesse-san, right? What, how can that we can let people? It's for use, no problem. To use across the platform, but for student, I don't know. Maybe we need to sign some contract or some CRA with IZ University or with your lab, and then your student can move on, can use.
Okay.
Yeah. For data right now, I think I can share your data. Okay. After that, you share your student, no problem. But I cannot share directly to your student. That you know that
Students,
because you are visiting researcher in NICT, so I can give you everything.
yeah.
And
No,
you
no,
also
that's
have
in general.
account.
If
Yeah.
someone wants to collaborate with you,
Okay. So can you write email to Jefferson to ask him directly?
okay, yeah,
Yeah,
just
and
this
I
is my
think
question.
it's not problem. Even
Yeah,
like
not be a problem.
something like I don't know, but we can give internship in NCT, so your student can come in NCT for 3 months or six
Yeah,
months, stay here and working. I don't think that's a problem. Yeah.
I want Narendra to do that. So I'm
Mm.
waiting for his results. Once he gets
Yeah.
something concrete, then I want to introduce him to
Yeah.
Jesse Sensei. Yeah.
Yeah. I think for next year we have bucket for internship because next year we start for new 5 years project.
Mhm.
So we have this year we cannot have anything. We cannot spend for extra thing, but next year as
Next year is
start a new,
2021. Yeah.
yeah, and then we have money. Even your Kakenhi, right? Your Kakenhi project, if you wins the Kakenhi
Yeah.
and then you have
No, that is there.
mm,
I have Aizu Daigoku budget also. So at any cost,
yeah,
Narendra will be coming. So I
okay,
promised him that you will
yeah,
come here. So he will come.
okay, yeah.
Yeah. And one
Um,
more thing I want to ask you was, are you applying for Media Award 2021 too? Are you conducting Media Award?
yeah, sure, yeah. So now I organize the ICMR workshop, okay, and media event 2021. Yes.
No. Yeah, because
Okay.
now I have formed the team. We will be
Mm.
participating in
Okay, it's good. Welcome.
it. Yeah.
And this year, like I told you, I just present on my slides. I mean, like we let the participant view across the platform,
Yeah.
or at
So we
least
have
we can.
to conduct our coding and experiments on the XData platform.
Yeah,
So
I mean,
is it
like
free to pay?
no, you not pay, but you can okay, we can give you the across the X virtual machine, right? So
That's
you
what.
can
Yeah.
install the virtual machine in your local server, and from that your local server, you can store your data, and you can code it on that local server, and then you call API with the center.
Mhm.
You call only API for the center, only API, and you call out API to build your own website or your own applications.
Got it. Yeah. Thank you, Dawson. So any other doubts from the students? Okay, they are not here. Okay. Anyway, okay, it's time also. Okay. Thank you very much,
Yeah.
Dawson.
Thank you.
Please stay safe in Tokyo.
Yeah, sure. And we stay at home now because no more time to. I mean, like now they have the emergency again.
Yeah.
So yeah, so I mean, like only 30% of staff should be in the office at time at one time.
Mm.
So I mean, like for me, only one day on office in the office. Mostly work at home.
Got it.
Yeah.
Okay. Thank you, Dawson.
Okay. And by the way, for Philippines, they already share data for Dengue.
Oh,
It's very
Philippines.
nice day. Yeah, Philippines. And I think I can share your data, and when you look in, maybe you can apply for the utility driven,
Mhm.
because
Utility or
I think,
unsupervised.
yeah, because they have hypothesis mean, like they have the relation, very high relation between the weather, the weather, the cleanliness, and the
Mhm.
density of the people, the habitants, and the dengue. So I think that you can apply your utility driven and to detect
Can
the,
introduce new
yeah,
algorithms. We
yeah,
have been using road data set, congestion data set for
yeah,
quite some time, 2 years.
yeah,
So we
yeah,
can move. I am
yeah.
expecting, so once Likita comes here or
Mm,
once they are free, then they will start
mm.
the work.
Okay, good.
Mhm.
And if you want, I can share your data for
Sure,
Philippines.
sure,
Yeah,
Dawson. Sure, yeah.
yeah, okay,
Yeah, that
okay,
we will discuss later. Yeah.
okay,
Okay.
okay. Thank you.
Bye,
And
Dawson.
then bye bye. Take care. Bye bye.
Bye. Okay. Thank you for everyone to attend for attending this talk. Okay. We will now close the session. Bye.